Hi there and welcome back. In this video we're going to be discussing the properties for segment lengths when they are intersecting either inside or outside the circle. So in your notes packet we're on section 10.6, segment lengths and circles. And before we look at these properties, I would like to review with you some vocabulary. So let's see, let's start out with a circle. And I want to have a tangent and a secant drawn in this circle. So here's a secant, and let's see, I'm going to make that so it's tangent. Oops. Okay, so there we have a tangent and a secant. Yeah, let's put that point B right there. There we go. Okay, so in our circle, we reviewed recently what the tangent actually is. So the tangent is just any line segment that is touching the circle at one spot. Now what we want to look at is this piece right here. From the point of tangent C out to the point outside the circle. Remember, this is the external tangent segment. Okay, and we'll say that that is for tangent. We'll make that a line. Ray DE. Okay, so that segment DB. So segment DB is the external tangent segment for tangent ray DE. Okay, up here we have DC. We'll call that a ray also. So ray DC is a secant, which we already knew. What we're interested in, though, is a new term. If we have this point where the secant intersects the circle, let's call that point F. We can say that this segment DF is the external secant. Okay? So external tangent segment and the external secant, where DF, segment DF, is the external secant. Okay, so we're going to need to know what those are for the next couple of properties. Okay, so let's go back to our notes. I don't have an animation for you for this particular lesson, so we're just going to kind of go through the properties, and then when you come back to class, we will do some practice problems together. So our first property, what is the relationship between the pieces of the segments when they intersect inside the circle? And in our diagram, we have two chords shown. Okay, so the relationship between these two, we have the chords that are made up with pieces of A and B. So I'm going to label this as big A and big B. And this other one I'm going to label as chord big C and big D. These chords are actually going to divide each other proportionally. So what that means is that we can take the pieces and multiply them together. So we can take little a times little b, and that's going to be equal to little c times little d. Okay. All right, our next one says, what is the relationship between the pieces of the segments when they intersect outside the circle? Okay, so here we have two secants. They're both intersecting at this external point. And again, I'm going to go through and label some of these. I'll label this as big A. We'll call this big B, big C, big D, and big F. Okay, so the relationship here is that we can take the external piece and multiply it times the whole entire piece. Okay, so it's external times whole thing. So external times the whole. And you're going to set those equal to each other. Okay, so if you want to write up like a little formula, we can say if we're looking at this first secant, a to d, so our first secant, a to d, if we take just this piece a, you're going to want to multiply times its whole thing, which is a plus d, so a plus d. And then we're going to set that equal to, on the other side, we've got its external piece, b, times its whole thing. And its whole thing would be b plus c. Okay, so we do the external piece times the whole length. Okay, and again, when you come back to class and we do some example problems, you'll see how that all works. Okay, and then our third one, it's kind of a similar situation. You still have two special segments that are intersecting outside the circle. This time we have a secant and we have a tangent. Okay, well, the tangent is special because its external tangent segment, which in our picture is A, the external piece is the same thing as the whole length, because all we care about is the piece that is either outside or inside the circle. So this segment, this external tangent segment, is the same thing as the whole length. So let's write that down. The external piece is the same as what we call the whole thing. Okay, but other than that, the formula you'll use for this is going to be exactly the same as the one that we just did. So kind of repeating that pattern, the external piece times the whole thing. In this case, the whole thing is just A. So it's going to be A times itself is equal to, for the secant, you do just like what we did in the second one. The external piece, which is B, and then times the whole thing, which would be B plus C. Okay, and then if you wanted to simplify this, we could call that A squared, because that'll always be the case, equals B times B plus C. Okay, so those are our three properties that we'll be looking at tomorrow when you come back to class. So you'll want to bring these with you. We have two chords. If they intersect inside the circle, then all we do is we multiply the pieces together. If you have intersection outside the circle, whether it be two secants or a tangent with a secant, it's always the external piece times the whole piece. Okay, so that'll be it for this video, and we'll see you in class.